G'day folks, me again. Well, for tonight's little equipment inspection, we're going to have a look at some more control gearboxes. I did show some ones I built up for the lower wattage lamps between 50 and 400 watts, but these ones are much larger than that. They're 1000 watts and they are very heavy, very chunky, and they do mean business. So let's have a look, shall we? Right, so the first control gearbox we're going to take a look at is the smallest of the three. It's designed to run a single 1000 watt high pressure mercury vapor lamp, but as there are metal halide lamps which are designed to run off mercury gear, I fitted it with a triggerable 750 volts parallel igniter, which you will see when we take a look at inside, which we'll do now. So this is inside. There's a Philips BHL 1000 L78 choke. There's also a Philips SI52 parallel igniter, and there's also 80 microfarads worth of power factor correction. Yeah, there's a nice big chunky steel enclosure. I've added a carry handle because they are bloody heavy. You'll have to excuse the wiring because it's not the neatest, but it works. Anyway. Right, so the next gearbox we're going to take a look at is designed to run high pressure sodium lamps. The choke in this is much chunkier and heavier, and again there are metal halide lamps which are designed to run off that gear. So let's have a look inside this one then, shall we? And this is inside the sun gear. It's a BSN 1000 L78 choke, which is much larger and heavier than the Mercury gear. It's a bit ratty because it's been rattling around the cupboard for the last 7 years before I decided to build this. Anyway, the igniter is an SN59 parallel type, which kicks out much higher voltage than the parallel type used in the Mercury. And we've also got 100 microfarads worth of power factor correction. Again, it's in a steel enclosure with nice chunky carry handles because it's bloody heavy and difficult to move. Anyway. Right, the last one we're going to be looking at tonight is this one, which is pretty special. I've been meaning to build it for years, and a while ago I finally got around to it. But anyway, it's designed to run a single 1000 watt CSI PAR 64 lamp, which is basically an incredibly bright metal halide reflector lamp which chucks out about 1.5 million candela. They were very popular in stadiums back in the good old days, and while ballasts for them do exist, they're rare as rocking horse shit. But as we'll see inside, there are ways to get around that. But anyway, I'd done a video of one of these years ago, and since, well then and since, when I wanted to run it, I'd have to cobble together a load of chokes on the floor, which wasn't ideal, and it was a pain in the arse, so it deserves a proper control gearbox, which is in front of you. So we'll have a look at that right now. This is what's inside. We now have 200 microfarads worth of power factor correction, and we have 3 chokes. Each choke is a 400 watt high pressure sodium choke, and they are all in parallel because the 1000 watt CSI runs with an arc current of 15 amps, which is quite high, between a voltage of 70 and 85 volts. Now, as I said before, the proper ballast for this is pretty much unobtainium at this stage, but I found in a Thorn technical journal from the 1970s, they state the control gear as being 3 400 watt sun ballasts. Maybe because the dedicated ballast wasn't available back then, but obviously that's what they said, and this is what I've got here, and I can confirm it does work rather well. The reason why there's a 3-phase plug on the end is because I need the conductors for obviously the earth, I need the neutral, the live from the ballast, and I also need a conductor to carry the trigger to the high voltage pulse transformer, which is located in the actual fitting itself to start the lamp. That's triggered by this toggle switch you can see there. You just hold it in for 3 seconds, and after that the lamp should start. Yeah, it's quite heavy, as you can imagine, and it does the job. I might have to do another video now I've got this, because it's a lot easier. Anyway, I think we should fire up some lamps, don't you? Let's do that. I think we should try a metal halide lamp. Anyway, this is a 1000 watt Philips HPIT Pro. We're talking 85,000 lumens, has a colour temperature of 4300 Kelvin. Colour rendering is about 65%, which is reasonable. The life to 50% failures is 12,000 hours, and these are overall pretty good lamps. These are designed to run off Mercury gear with the ignitor. So without further ado, let's fire it up. Right, I've closed the aperture right down and I put it on auto ISO, so hopefully we might see a good run up. So main power, oh, I didn't even need the igniter then. This is a new lamp. Obviously as it ages it will need the igniter. Well, that didn't work. The lamp ran up so quickly it just swapped the camera out, so I cut and went straight to the macro lens with the ND filter. And we can see there's a beautiful view of the arc. That is a nice arc. The colour from this lamp is really beautiful. It's a really crisp, cool white light. Metal halide is beautiful technology. It is bloody bright. It's reflecting off everything. Quite dazzling. Let's see if we can get a view of one of the electrodes there. Right, there's one of the electrodes. It's pretty hard to get a clear shot really because of the curvature of the quartz arc tube and also the outer jacket. But anyway, you can see the tip there. Do you think the tip's warm? I think it's warm. Yeah, that's a pretty unique view. It's not often you see something like this. And it is bloody bright. And it is quite warm. It is getting warm in this room. Anyway, I hope you found that interesting. Hopefully I'll have some more videos out soon. Thanks for watching. Bye bye now. Oh, that's warm.